All right, here we go. Answer key for Mr. Young's IM3 review exam. We are imagining that in 1970, $20,000 was invested, growing at an annual rate, compounded yearly at 6%. So you've got your initial amount, $20,000, and it's going to be 1 plus 0.06. That's the interest rate, and that's going to keep the original. So you're not just taking home the interest, it's the original plus the interest. And we'll say this is the amount, and we're going to write it as a function, so it's a of t. And then that means our variable is t, so I'm going to raise it to that exponent. All right? And we then, to evaluate a of 1970 to 2006 is 36 years. It's just 20,000, and then it's 1.06 to the 36. Okay? Plug that in your calculator. I'll do this once. After this, you're kind of on your own. 20,000, and then 1.06. You can just do the parentheses like that, caret to the 36. Be careful to follow the PEMDAS rules, and you get $162,945.04. Okay? Going in reverse, trying to figure out how long it takes to get to a certain level, you're just going to write an equation, 30,000, and that's equal to the above amount. And then we're just going to use logarithms to solve for t. That's the variable up there, t. And so when I divide both sides by 20,000, I get 1.5 equals 1.06 to the t. Now I take the log of both sides, common or the natural log, it does not matter. So I get the ln of 1.5 is equal to the ln of 1.06 to the t. Well, that t comes out front, and I divide both sides by the ln of 1.06. So t is equal to the ln of 1.5 divided by the ln of 1.06. Okay? So you can do that in your calculator. I think it's like 6 or 7 years. Since 1980, when they started buying computers, it's grown exponentially. It's very important that you read that word. If not, you could assume it's linear or something. 720 in the year 2000. So that's like our initial data point, that the year 2000, there's 720. And then in 2001, there are 828. You need 2 data points and the knowledge that it's exponential to make this work. So it's not a big deal. We just say you can pick any year to be your starting year if you know the growth factor, and it's growing by this much as a multiplier in 1 year. So you simply write 720, and that's going to be multiplied by the fraction 828 over 720. I think decimally it's about 1.15, and that's raised to the t, and that's going to give you your number of computers. I'll just put it again in function notation. And then when you're asked how many computers did the school have in 1970, well, that would be 30 years before the year 2000. You could plug in negative 30, but we're too clever for Mr. Young here to fall for this trick, because that's 10 years before they started buying computers. So that's going to be equal to 0, or whatever you want to interpret as that. 1992, however, we can do that. That's n of negative 8 years before the year 2000, so I 720 it. And then this, I'm going to call this just 1.15 for clarity, and that's to the minus 8. And you plug that into your calculator. And so 720, I'm not off the screen there, I got to be careful, 720, and then times 1.15 caret to the minus 8, negative 8, and that's 235 approximately computers. Okay. Then how many will there be in 2025? That's going to be n of 25, and that's 720, 1.15 to the 25. Same type of thing, and you can see what that is in your calculator. What year will there be about 2 1,200 computers. Now we're going to be solving backwards using our logarithmic skills again. 1.15 to the t. So just like this solution up here, you can, with a little bit of practice, you can see that it's going to be t is going to be equal to the ln of 2,200 over 720, then divided by the ln of 1.15. Okay, again, I'll let you put that into your calculator and see what that is. And again, I hope I haven't chopped that off. I'll give you a little screenshot there of the process in case I did. Alright, these guys now, these are of the same base, so that's going to be 9 to the 1/3 plus 1/6. That equals 9 to the 3/6. When we get a common denominator and add, that equals 9 to the 1/2, which equals the square root of 9, which equals 3. Right? That's A. So for B then, this is going to be, get rid of the negative by flipping it upside down. And that's to the 3/2, and then that's the same as the square root of 16 over 25 raised to the 3rd, which is equal to 4 over 5 to the 3rd, and you can write 64 over 125. That's probably what most textbooks would want, and Mr. Young as well. Simplified. You could leave it like this, and that's not wrong. When you're taking the square root of x to the 7th and y to the 8th, think of that as 1, 2, 3, 4, 5, 6, 7, and then y to the 8th. This will just illustrate that you're looking for pairs of x's that come out, and there are 3 pairs that come out. So this gives us then x to the 3rd, and there are 4 pairs out of the 8 y's that come out, and what's left behind is this one lonely x right there. Okay? So that's the answer for C. D, you do the same thing, but you're looking for triples, right? So this is going to be the cube root of 2 times 2 times 2. That's 8 broken down. And then A times A times A times A. 4 of those. Well, you're looking for groups of 3 because that's a 3 right there. So this is going to then yield 2ab to the 2nd, and what's left behind is the cube root of a. And leave that, make it really clear that that's a cube root. It's not just a random 3 that's appearing. And then finally E, you do the same thing as we did in the first one. These are the same base, so this is going to be w to the 2/3, that's the root, that's 3, and that's the exponent, that's 2, times w to the negative 2 over 6, so that's going to be equal to w to the 2/3 minus 1/3, which equals w to the 1/3, or the cube root of w, depending on how you want to answer that. Either one of those answers is good. Okay? So that's page 1. Page 2 here is find the value of $1,500 invested for 5 years at an annual rate of 8.34%. So if it's monthly, that's going to be an amount based on time. That is our initial $1,500. And then it's 1 plus that rate, 0.0834, don't get faked out by the decimal, divided by monthly is 12 times a year, and then that means you're going to have to compute the interest 12 times over those 5 years. Alright, so again, you just grab the old calculator and you evaluate this much like the other one. So $1,500 parentheses, and now we are going to do 1 plus, and then 0.0834 divided by 12, close parentheses, caret to the, well, 12 times 5 is 60, so I'm going to, if I just type in 12 and then multiply it by 5, it'll be wrong. If I want to put it all together, 12 times 5 in parentheses will give me the correct answer, and that is approximately $2,272.83. 82 cents. All right. Daily, you're going to type in the same thing, but these will both go to 365 right there. 365, and you'll crunch those numbers. It'll be a very similar number. I'll write that down up here. And continuously, though, that is going to be the amount, varies with time according to the principal, 1500, then e to the 0.0834 times 5. Okay, I'll do times 5 like that. And again, put that in parentheses. So you can find that in your calculator here, 1500, and then times second e, second ln gives you e caret to the 0.03834 times 5, close parentheses, and that's approximately 22.76 and 10 cents. All right, so you can see there's $4 whole or so is gained by going from monthly to instantly. Not a big return on that, but important if you have big sums of money or long periods of time. Finding the inverse. All right, so we are going to go through those steps of swapping the y and the x, and then solving for y. So I'm going to subtract 5. Show your steps. X minus 5 equals negative 4y. Then I'm going to divide by negative 4. And I'm going to get then f to the minus 1 of x. Put it in function notation. Show that it's an inverse. And you could leave it like this, but better to distribute the negative in and then write it in this fashion, I would think. X, 5 minus x, right? Because when I bring the negative sign up, that becomes plus and that becomes minus, so then you write that over 4. Alright, so that's probably the best way to write that answer. Although negative x plus 5 would be fine. Even leaving like that would be okay. Here I do the same thing. X equals the square root of y minus 5. I square both sides, and then I add 5, and I get f to the minus 1 of x is equal to x squared plus 5. But I'm not going to ignore the fact that I have to follow the rules for inverses, and it has to pass the vertical and horizontal line test. So I'm going to restrict the domain to be greater than or equal to 0. Alright? So please remember that. Here I do the same thing. X equals y plus 3 to the 5/3. So I get rid of the 5/3 by raising it to the reciprocal power. So x to the 3/5, because when I raise this to the 3/5, the exponents multiply and turn into 1, and poof, they're gone. And that's y plus 3. So this one then is going to be f to the minus 1 of x is x to the 3/5 power, then minus 3. There we go. And now this one is why we invented logarithms. It's going to be x equals e to the y. So to get that y by itself, I take the ln of both sides, and that is going to be then y equals the ln of x. This one also has a restriction on the domain. Here, there's no way the outputs are ever going to be 0 or negative. So here the inputs, I should say, x is going to be greater than 0. X must be greater than 0. You can't plug in 0, you can't plug in any negative number. Alright, evaluate. You can't use a calculator. This is all based on the definition of what a logarithm is. Make this equal to some imaginary x value. Use your little arrow method. Cover up the log. So 5 to the x is equal to 125. I think that's out of the quiz. So x equals 3. So there's your answer. It's equal to 3. Here, the log base anything of 1 is always equal to 0. You can just do that because you should know it. But if you write it in exponential form, you'll see that 6 to the x is equal to 1. Well, the only value that'll work is 0. Here, the 3 comes out front because that's our rule of logarithm, and the log base e of e is 1, so this whole thing is just equal to 3. And here again you can just say, well, that's equal to x. 16 to what exponent gives you 4? 16 to the 1/2 power gives you 4, so x equals 1/2. Alright, again, no calculator. That's no calculator, that's no calculator. Same thing, x to the -2. Well, if you have 25 equals x to the -2, that's equal to 1 over x to the +2. If you want to put this over an invisible 1 and then cross multiply, you get 1 equals 25x squared. Divide both sides by 25. You get x squared equals 1/25. So x equals, where can I sneak it? Right here. X equals 1/5 when I take the square root. That's A. Here, e to the x equals the cube root of e, so that's just e to the 1/3, so x equals 1/3. It's all just understanding what exponents are. E to the x equals 17. Well, if you take the log ln of both sides, then that x comes out front, and poof, the ln of e cancels, so this x is just equal to the ln of 17. That's the only way you can answer that without a calculator. You could guesstimate. It's going to be, e squared is around 7, and multiplying by 2 again would probably be about 3, something close to 3. Here, with no calculator, A and B no calculator. Here you do plug it in your calculator. Oh, I'm sorry, I didn't read the directions. Turn that on, clear that out. ln of 17, I would guess 2.83. Approximately equal to 2.83. Then this one, you take the log of both sides, so you get the log, doesn't matter common or otherwise, the log of 12 to the 2x, that comes out front again, is equal to the log of 7. So then you've got 2x is equal to the log of 7 over the log of 12. And when I get that answer, I divide by 2. So divided by 2 equals x. So that then gives us x is approximately, let's try it quick, and you can do the ln if you want. I'm just trying to share the love. Log of 12, and then I get that, and I divide by 2. So 0.3915, 0.392. I said usually you just go to 3 decimal places, so you're good. Okay. Again, more solving. I'm going to divide both sides. Oh, sorry, I'm going to subtract 3. I didn't see that. Just go step by step, layer of an onion type of thing. That equals 26, and that's 1.05 to the x. So I now take the log of both sides. It does not matter which one, so I'll bounce back to ln. Again, this comes out front, and x is equal to ln of 26 divided by ln of 1.05. I won't bore you with doing it on the calculator. You should check it out on your own. Here we've got logs that are being added, so we can multiply them with a single log. So x times x minus 15 equals 2. I don't have to do anything other than on the left side combine these. So I can then say, well, whatever, this is base 10. Since we're not told anything else, we have to assume it's base 10. Arrow method brings that over. So x squared minus 15x equals 100. See where that comes from? The 10 as an exponent, sorry, 10 comes as a base with the 2 as the exponent. 2 squared is 100. Then it's a quadratic, so I know by muscle memory to bring that over, set it equal to 0, and then try to factor it. Can you think of two things that multiply to make 100 that subtract to make 15? I think 5 and 20 will do that. So x minus 20, x plus 5. That's only going to be true if x is equal to 20 here, or x is equal to negative 5 here. And I know that I cannot take the log of a negative number, so it's got to be the one single answer, x equals 20. Alright? Same thing here, you're going to bring this in as an exponent, and then subtracting means division, so I've got the log of x squared over 3x minus 10 equals 3. So when I bring the 10 over as a base to that 3, I get x squared over 3x minus 10 equals 1,000. 10 times 10 times 10. If I cross multiply, then I get 3,000x minus 10,000 equals x squared. So I get x squared equals, x squared minus 3,000x plus 10,000 equals 0. And how's our factoring now? Well, let's see, can I think of two numbers that multiply to make 10,000 that differ by 3,000? How about x minus, let's see, 200, no, I will use quad form for that and post that on the answer key. That's probably staring me in the face, but I don't want to have you even spend wasted time trying to watch me factor that. I'm going to punt to the next one. Here we go. Let's see how much time is left. Alright, I'm done.